For more than 70 years, we believed our map of the solar system was settled. 9 planets, clear borders, a neat cosmic order that felt permanent. But far beyond the last known planet, in the frozen darkness billions of kilometers from the sun, something was quietly moving. A faint point of light, drifting so slowly it escaped notice for years. Its discovery wouldn't add a new planet, it would erase one. And in doing so, it would change Pluto forever and force astronomy to confront what the word planet truly means. For decades, astronomers believed the outer solar system was largely understood. Beyond Neptune lay Pluto, small, distant, and strange, but comfortably alone. The idea that Pluto was a unique planetary oddball at the edge of the Sun's domain felt oddly unsatisfying, yet no clear alternative had emerged. That assumption began to crumble in the early 2000s, not through a single lucky observation, but through a painstaking effort to take inventory of the Sun's most distant companions. At the Palomar Observatory in California, a small team of astronomers set out to systematically survey the outer reaches of the solar system. Their goal was simple in concept, but monumental in scale: search for objects orbiting beyond Neptune, bodies known as trans-Neptunian objects. Using a wide-field telescope paired with automated image-searching software, the team captured vast regions of the sky, night after night. The software flagged faint points of light that moved at specific speeds, separating distant solar system objects from the fixed background of stars. The approach worked. New worlds began to emerge from the darkness, icy bodies like Kuiper, Orcus, and Sedna, each discovery hinting that Pluto might not be as alone as once believed. But the team was hoping for something more, something larger. Convinced that the solar system still held a hidden giant far beyond Neptune, one of the astronomers made a decision that would change planetary science forever. Instead of relying solely on automated detection, he began manually re-examining old datasets, images the software had already passed over. It was slow, tedious work, involving months of rechecking and comparing photographs taken years apart. Then on January 5, 2005, everything changed. While clicking through a sequence of images taken in October 2003, a single faint dot stood out. It was moving, barely, but unmistakably. Against the backdrop of fixed stars, it drifted at a glacial pace, far slower than any object previously found. Its brightness suggested it was either unusually reflective or remarkably large. Its sluggish motion implied something even more startling. It was incredibly distant. The realization was immediate and electric. This wasn't just another icy fragment in the outskirts of the solar system. It looked like a planet. The object was temporarily designated 2003 UB313, and the team began quietly tracking it to determine its orbit and size. Their plan was to wait, gather more data, refine their measurements, and avoid premature conclusions. But the competitive world of planetary science had other plans. When rival teams announced similar discoveries, the pressure became impossible to ignore. In July 2005, the team went public, revealing not one but multiple major bodies lurking beyond Neptune, including the mysterious object that would soon ignite a scientific firestorm. The solar system had just revealed a world that challenged everything astronomers thought they knew, and Pluto's future was suddenly uncertain. At first, the discovery of 2003 UB313 seemed like a triumph. Astronomers had found what appeared to be a long-suspected 10th planet, lurking far beyond Neptune in the frozen outskirts of the solar system. But almost immediately, celebration gave way to confusion and then to conflict. Initial estimates suggested this object was at least as large as Pluto, possibly even bigger. When further observations revealed it had a moon, astronomers were able to calculate its mass with far greater precision. The result was undeniable. This distant world was roughly 27% more massive than Pluto. If Pluto was truly a planet, then logic demanded that this object must be one as well. And that single fact shattered the fragile order of the solar system, because if this new world qualified as a planet, then it couldn't stand alone. Other large bodies discovered in recent years, objects like Kuiper, Sedna, Haumea, and Makemake, suddenly demanded answers too. Were they planets as well? If so, how many planets did the solar system really have? 10, 12, 20, or dozens? Astronomers found themselves trapped in a logical crisis. Either they had to dramatically expand the list of planets, or confront the unthinkable possibility that Pluto itself might not belong on that list at all. As one astronomer bluntly summarized the dilemma, we were either going to have to add planets or subtract one. The discovery of this distant world did more than add a data point. It forced scientists to confront a question that had never been formally resolved. What does the word planet actually mean? For centuries, the term had been used loosely, shaped more by tradition than by strict definition. But now, tradition was no longer enough. In 2006, the International Astronomical Union, the global authority responsible for astronomical naming and classification, was forced to act. At its General Assembly in Prague, the organization held the first formal debate and vote in history on the definition of a planet. What followed exposed deep divisions within the scientific community. One group argued for a geophysical definition. In their view, a planet should be defined by its intrinsic properties. If an object is massive enough for its gravity to pull it into a nearly round shape, a condition known as hydrostatic equilibrium, it should be considered a planet. Under this definition, Pluto would remain a planet. So would the newly discovered object, and so would many others. The opposing camp argued for a dynamical definition. To them, a planet's identity depended not just on its shape, but on its dominance. A true planet must have cleared its neighborhood, meaning it must be the gravitational master of its orbital zone, sweeping away or controlling nearby debris over time. The debate was intense and deeply consequential. When the vote was finally held, controversy followed immediately. Only a small fraction of astronomers were present, as many had already left the conference. Yet the decision stood. The dynamical definition won. A new three-part rule was established. A planet must orbit the Sun, be nearly round, and have cleared its neighborhood. Pluto met the first two criteria, but failed the third. In an instant, a new category was born: dwarf planet. Pluto was no longer a planet. The solar system was officially reduced to 8. And the discovery that made this decision unavoidable had changed Pluto forever. The decision to redefine the word planet did not bring closure. Instead, it ignited one of the most controversial debates in modern astronomy. Almost immediately, critics began to question not just the outcome of the vote, but the process itself. The final decision had been made on the last day of a 10-day conference, after most of the more than 2,500 attendees had already left. Only a few hundred astronomers remained to cast their votes, representing a small fraction of the global scientific community. To many, it felt less like a consensus and more like a ruling made by circumstance. The definition itself drew even sharper criticism. The requirement that a planet must have cleared its neighborhood was seen as vague and poorly defined. How clear is clear enough? Even Earth shares its orbit with near-Earth asteroids. Jupiter coexists with Trojan asteroids. By this logic, some argued, no planet truly clears its neighborhood completely. Others pointed out a deeper flaw. The definition applied only to objects orbiting the Sun. It worked for our solar system, but ignored the thousands of exoplanets now known to orbit other stars. Rather than a universal principle, critics said, the definition was a local, reactive fix to an unexpected discovery. Despite the backlash, the ruling stood. Pluto was officially reclassified as a dwarf planet, joining a new category that also included Ceres, once considered an asteroid, and other distant icy worlds. But crucially, a follow-up proposal that would have made dwarf planets a subcategory of planets was rejected. Planets and dwarf planets were declared fundamentally different classes. To many, this felt like an unnecessary downgrade. Pluto hadn't changed. Its orbit, size, and composition were exactly the same as they had always been. What had changed was humanity's definition and the solar system story. Public reaction was swift and emotional. Pluto had been taught in classrooms for generations. It was part of cultural memory. The idea that it had been demoted struck a nerve far beyond scientific circles. Yet beneath the outrage, a quieter realization was taking shape. The discovery that forced Pluto's reclassification had revealed something far more profound. The solar system was not a simple, orderly structure with a single oddball at its edge. It was a complex, layered system filled with entire populations of worlds still waiting to be understood. And at the center of that realization was the distant world responsible for the upheaval, a world whose name would soon become synonymous with cosmic discord. With the debate over Pluto's status raging, attention finally turned to the object that had ignited the crisis itself. The distant world once known as 2003 UB313 was given a name that perfectly reflected its impact on astronomy: Eris, after the Greek goddess of discord. Just as her mythological counterpart had sparked chaos with a single golden apple, this frozen world had thrown planetary science into turmoil. Eris does not reside in the relatively orderly Kuiper belt, where Pluto and many other icy bodies orbit in a flattened disk beyond Neptune. Instead, it belongs to a far more chaotic region known as the scattered disk, a sparsely populated halo of objects with extreme elongated paths around the Sun. These worlds are the outcasts of the solar system, likely formed closer in before being violently flung outward by gravitational encounters with Neptune billions of years ago. Eris's orbit is among the most extreme known. It takes roughly 557 Earth years to complete a single journey around the Sun. At its closest approach, it comes to within about the same distance from the Sun as Pluto's average orbit. But at its farthest point, Eris swings out nearly 3 times farther than Pluto ever does, plunging deep into the frozen darkness of interstellar space. Its orbit is also steeply tilted, so inclined that Eris spends most of its long year soaring far above and below the plane where the planets travel. For years after its discovery, Eris was thought to be larger than Pluto, but in 2010, astronomers finally measured its size with extraordinary precision during a rare stellar occultation when Eris passed directly in front of a distant star. By timing how long the star's light was blocked from multiple locations on Earth, scientists were able to calculate Eris's diameter with remarkable accuracy. The result was unexpected. Eris was almost exactly the same size as Pluto, and in fact, slightly smaller. But size was only part of the story. Thanks to the discovery of Eris's moon, astronomers could determine its mass for the first time. By tracking the moon's orbit and applying the laws of planetary motion, they found that Eris is 27% more massive than Pluto, despite being slightly smaller. This meant Eris was far denser, suggesting a very different internal structure. While Pluto appears to be a mix of rock and ice, Eris is thought to be predominantly rocky, wrapped in a relatively thin icy shell. Beneath its frozen surface may lie a dense, solid core, giving Eris a gravitational strength that Pluto simply could not match. Eris's surface itself is one of the brightest in the entire solar system. It reflects nearly all the sunlight that reaches it, making it appear dazzling white even at immense distances. This brilliance is likely caused by a process known as atmospheric collapse. As Eris travels far from the sun, its thin atmosphere freezes and falls onto the surface as fresh frost. When it slowly returns inward over centuries, that frost sublimates back into gas, only to freeze again as the cycle repeats. More recently, observations have hinted at something even more surprising. Subtle variations in the composition of methane ice on Eris's surface suggest that some of it may have been altered by internal heat. Despite its distance and cold, Eris may possess, or once possessed, a warm interior, challenging assumptions about how inactive such distant worlds should be. The final piece of evidence that sealed Pluto's fate came from Eris's moon. Its existence allowed astronomers to definitively measure Eris's mass and confirm that this distant world was not only Pluto's equal, but its superior in one crucial way. Once that fact was known, the planet debate was no longer theoretical. If Pluto was a planet, Eris had to be one too. And if Eris was a planet, the solar system could no longer remain the same. In the years since the historic vote of 2006, the discovery of Eris has often been reduced to a headline: the Pluto killer, the object that took a planet away. But that framing misses the deeper truth of what really happened. Eris did not destroy Pluto's identity, it revealed it. For decades, the solar system had been described using a flawed model: 8 familiar planets, and then one strange outlier at the edge, Pluto. Its odd orbit, its small size, its icy nature, all made it seem like an exception, a cosmic mistake that somehow slipped into the planetary club. Eris changed that perspective forever by forcing astronomers to confront the existence of an entire population of similar worlds beyond Neptune. Eris revealed that Pluto was never alone. It was simply the first known member of a vast hidden realm, a third zone of the solar system filled with icy dwarf planets, remnants of planetary formation scattered into distant, extreme orbits. Instead of a demotion, Pluto gained a family. Today, the structure of the solar system makes far more sense. There are the 4 small rocky terrestrial planets close to the Sun. There are the 4 massive gas and ice giants dominating the middle region, and beyond them lies a sprawling frontier of dwarf planets, thousands of worlds like Pluto and Eris, orbiting quietly in the darkness. Eris and Pluto are not failures of classification. They are the kings of this distant domain, and yet Eris itself remains one of the greatest mysteries we know. It is the most massive object in the solar system that has never been visited by a spacecraft. While NASA's New Horizons mission transformed Pluto from a blurry point of light into a complex, dynamic world, Eris remains almost entirely unexplored, its secrets locked billions of kilometers away. A proposed mission to Eris would take decades to reach its destination. The journey would span generations. For now, Eris remains a distant beacon, reminding us how much of our own cosmic neighborhood is still unknown. That is the real legacy of the discovery that changed Pluto forever. It didn't close a chapter in astronomy, it opened one. It showed that even the most familiar diagrams can be wrong, that definitions we take for granted can collapse under new evidence, and that the most important discoveries are often the ones that force us to admit how incomplete our understanding really is. Pluto didn't fall from grace. Our perspective evolved, and somewhere in the frozen outskirts of the solar system, the goddess of discord still drifts in silence, having already done her work. If this story changed how you see the solar system, consider subscribing for more discoveries that rewrite what we think we know about our universe.